Hi everyone, I'm Mr. Fullerton, and today I'd like to talk to you about the wave equation. Our objectives are going to be to calculate period, frequency, and wavelength, and understand the relationship between these characteristics of a wave. So frequency, F, describes the number of waves that pass a given point in a time period of 1 second. So if you had 5 waves per second, your frequency would be 5 hertz. The units are 1 over seconds, or hertz, which we abbreviate with the capital HZ. More frequencies, higher frequencies, more waves per second. Lower frequencies, fewer waves every second. Period is very closely related to frequency. Period describes how long it takes for a single wave to pass a given point. So it's the reciprocal of frequency. Period is equal to 1 over frequency, and frequency is equal to 1 over period. The units of period are seconds, therefore the units of frequency again are 1 over seconds. So, sample problem 1. What is the period of a 60 hertz electromagnetic wave traveling at 3 times 10 to the 8th meters per second? Well, we know its frequency is 60 hertz, or 60 1 over seconds. We know its velocity is 3 times 10 to the 8th meters per second. We want to know what its period is. Well, to get period, if we have frequency, that's just 1 over the frequency, or 1 over 60 hertz, or 1 over 60 1 over seconds, which is equal to 0.0167. And if you have 1 over seconds, that's 0.0167 seconds. One more. The product of a wave's frequency and its period is what? Well, frequency times period equals, well, if period is 1 over frequency, we could write this as frequency times 1 over frequency, which is equal to 1. So a wave's frequency times its period must always be 1. Now, when we talk about wave velocity, we have to realize that since waves travel through some sort of distance, they therefore have a velocity. They travel some distance in some amount of time. The velocity of a wave is a function of the type of wave and of the medium it travels through. That's very important. Wave velocity depends on 2 things: the type of wave and the medium it travels through. For example, electromagnetic waves, things like light moving through a vacuum, travel at 3 times 10 to the 8th meters per second. That's such an important and common number in physics we use so often we give it the special abbreviation lowercase c. C is the speed of light, or the speed of electromagnetic waves in a vacuum, 3 times 10 to the 8th meters per second. Really, really fast. The wave equation says for a given wave speed or wave velocity, as frequency increases, wavelength must decrease. So the wave velocity is equal to frequency times wavelength. Now what's important to note here, the wave velocity doesn't depend on frequency and wavelength. You can't increase the frequency of a wave and have it speed up. This is a relationship that shows you
how the frequency and the wavelength are related.
Let's see how this works. What is the wavelength of a wave having a frequency of 5 hertz, frequency is 5 hertz, and a speed of 10 meters per second? Well, if velocity is equal to frequency times wavelength, then we could say that wavelength equals velocity over frequency, or 10 meters per second, divided by 5 hertz, or 5 over seconds, is going to give us a wavelength of 2 meters. Pretty straightforward. Let's try another one. If the amplitude of a wave is increased, the frequency of the wave will decrease, increase, or remain the same. Well, if you recall, we don't have any relationship between amplitude and frequency. So, if amplitude goes up, it doesn't do a thing to the frequency. The amplitude is independent of frequency, so the frequency will, 3, remain the same.